How would you solve an equation that looks like that? Y double prime minus 5y prime plus 6y is equal to 0. How would you solve that differential equation? In this video, we're going to talk about it. But first, you may want to have a sheet of paper with you to take down some notes. So we're going to talk about how to solve second-order linear differential equations. Now, these type of equations are usually in this form, where p of x, q of x, and r of x are continuous functions. Now, when g of x is equal to 0, what we have is a homogeneous linear equation. If g of x equals some other number, if it doesn't equal 0, then we have a non-homogeneous equation. Now, when p, q, and r are constant functions, we have this equation: a y prime plus b y prime plus y plus cy rather, equals 0. And a typical solution of this equation is in the form y is equal to e to the rx. If you take the first derivative of that, you're going to get r e to the rx. And if you take the second derivative of that, you're going to get r squared e to the rx. So substitute in y prime, and y double prime, we get a times r squared e to the rx, and then replace in y prime with r e to the rx, and then replace in y with just e to the rx. So we're going to factor out e to the rx. And so we're going to have ar squared plus br plus c is equal to 0. Dividing both sides by e to the rx, we get this equation: ar squared plus br plus c is equal to 0. Now, when we have that equation, what we want to do is solve for the value of r. There's two things we can do in order to get that done. We could factor, or we could use the quadratic formula, which will be r is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, there's three cases that you need to be familiar with when solving for r. The first one is when the discriminant b squared minus 4ac is greater than 0. When that happens, you're going to have two real unequal roots or solutions. So for example, r might be equal to 4 and r might be equal to negative 3. So those would be two real roots. In this situation, you could usually factor this quadratic expression. Now, when you have this situation, the general solution to the differential equation will be y is equal to c1 e r1x plus c2 e r2x. And all you got to do is plug in r1 and r2 into that formula. So this would be r1, that would be r2. And that will give you the general solution. When dealing with an initial value problem or a boundary problem, you need to solve for c1 and c2. Now let's move on to the second case. This is when the discriminant b squared minus 4ac is equal to 0. In this case, you get one real root. Like, for example, r would equal 5, but just one answer. So the general solution for this equation will be y is equal to c1 e to the rx plus c2 x e to the rx. So we don't have the subscripts r1 or r2 for this case. In the third case, the discriminant b squared minus 4ac will be less than 0 or negative. In this case, you're going to get imaginary numbers or complex numbers. So you'll have to use the quadratic formula. So r1 and r2 will be in this format. You'll have r1 is equal to alpha plus beta times I, and r2 is equal to alpha minus beta times I. Now, once you have alpha and beta, you could use this formula to write the general solution. So it's going to be e alpha times x times c1 cosine bx, or beta x rather, plus c2 sine beta x. So that will be the general solution for the third case. Now let's go back to this equation. Y double prime minus 5y prime plus 6y is equal to 0. Let's talk about how we can solve this differential equation. So first, let's write this quadratic function below it. AR squared plus BR plus C is equal to 0. A is 1, B is negative 5, C is 6. So replacing those values, we're going to have 1r squared minus 5r plus 6 is equal to 0. Now, for this quadratic expression, we don't need to use a quadratic formula. We could simply factor it. So we need to find two numbers that multiply to the constant term but add to the middle coefficient. So we know 2 times 3 is 6, but adds up to positive 5. But negative 2 and negative 3, it still multiplies to positive 6, but adds to negative 5. So we're going to write this as r minus 2 times r minus 3. So we get two real solutions for r. So this is case 1. So now that we have the values of r, we can write the general solution. So here's the general formula for case 1. It's C1e r1x plus C2e r2x. Substitute in r1, let's call this r1, and we'll call that r2. So let's replace r1 with 2, and then let's replace r2 with 3. So this is the general solution to the differential equation. That's the answer. Now let's consider this example. Y double prime minus 6y prime plus 9 is equal to 0. So once again, let's write this formula below it. AR squared plus BR plus C is equal to 0. A is 1, B is minus 6, C is 9. So now we need to factor this quadratic expression. So we need to find two numbers that multiply to 9 but add to the middle coefficient of negative 6. So this is going to be negative 3 and negative 3. So to factor it, it's going to be r minus 3 times r minus 3. So we can write that as r minus 3 squared, which equals 0. So we can clearly see that r is equal to 3. Now we have one solution, one real solution. And so the general solution is going to look like this. This is the formula for it. Y is equal to C1 e to the Rx plus C2x e to the Rx. Don't forget about this x. I know I've made that mistake in the past. So just remember that it's there. We don't need the subscripts R1 or R2 because there's only one R value here. So it's going to be C1e, replacing R with 3, and then plus C2x e to the 3x. So this right here is the solution, or rather the general solution of the differential equation. So that's how you could solve it when you have the second case. That is when you have one real solution. Now let's try another example. Let's say we have 9 times d squared y over dx squared, and then plus 24 times dy over dx plus 16 is equal to 0. So feel free to pause the video and try that problem if you wish. If you see it in this form, you could put it back into a form that you're more familiar with. D squared y dx squared, we can just replace that with y double prime. dy dx, we can replace that with y prime. So we have this. So now, let's write this equation, AR squared plus BR plus C is equal to 0. So we can see that A is 9, B is 24, and C is 16. Now, notice that 9 and 16 are perfect squares. 3 squared is 9, 4 squared is 16. So if we take the square root of 9 and the square root of 16 and double it, notice that this gives us 24, the middle coefficient. When you see that, that tells you you have a perfect square trinomial. So to factor it, it's going to be the square root of 9r squared, which is 3r, plus the square root of 16, which is 4, squared, equals 0. So solving for r, we have 3r is equal to negative 4, dividing both sides by 3. We get one solution. R is negative 4 over 3. So because we have one real solution, this tells us that we have case 2. Now, before we write the general solution, let's talk about what you could have done if you didn't realize it was a perfect square trinomial. So let's say if you wanted to factor that trinomial, what you need to do is multiply 9 by 16. So 9 times 16 is equal to 144. Now you need to find two numbers that multiply to 144, but add to the middle coefficient 24. So this is going to be 12 and 12. 12 times 12 is 144, but 12 plus 12 adds up to 24. Now your next step is to replace the middle term with 12r plus 12r. So mathematically the value is still the same. 12r plus 12r adds up to 24r. Next, factor by grouping. So in the first two terms, take out a 3r. You'll be left with 3r plus 4. And then in the last two terms, take out the GCF, which will be 4 in this case. So 12r divided by 4 is 3r. 16 divided by 4 is 4. The fact that these two are the same tells you that you are on the right track. So if you factor out 3r plus 4, you'll be left with 3r plus 4, which is the same as what we have here. So now we can write the general solution for case 2. So it's C1 e raised to the rx plus C2x e raised to the rx. So all we need to do is replace our r value, which is negative 4 over 3. And so this is the answer. This is the general solution of the differential equation. And as you can see, it's not that bad. So as long as you know what case you're dealing with and you know which general solution you need to work with, once you have your value of r, just plug it in and you'll get the answer. Here's another one that we could try. Y double prime plus 8y prime plus 25 is equal to 0. Go ahead and try that one. So let's write this formula first. We could see that A is equal to 1, B is 8, and C is 25. Now to find two numbers that multiply to 25 and at the same time add to 8, that's not going to happen. So we can't really factor this expression, which means we need to use the quadratic formula. So r is going to be negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we said that b is 8. So we have b squared, which is 8 squared or 64, minus 4 times a times c. c is 25. a is 1. Divided by 2a, or 2 times 1, which is 2. So this gives us negative 8 plus or minus. Now, 4 times 25 is 100. And 64 minus 100 will give us negative 36. The square root of 36 is 6. The square root of negative 36 is 6 times the imaginary number I. Negative 8 divided by 2 is going to give us negative 4, and 6 divided by 2 is 3. So we get this. So we have two equations. R1 is going to be negative 4 plus 3i, while R2 is negative 4 minus 3i. So now let's get rid of this. Now once you have the answer in this form, you also want to write this expression. R1 is alpha plus beta times I. R2 is alpha minus beta times I. So in this form, you could see that alpha is -4, beta is 3. So let's go ahead and write that. Now, once we have our alpha and beta values, we can now find the general solution. By the way, the fact that we have two complex numbers or two imaginary numbers tells us that we have case number 3. So the general solution for case number 3 is this. Y is equal to alpha times x, e raised to the alpha times x, and then times c1 cosine beta x plus c2 sine beta x. So let's replace alpha with -4, and then let's replace beta with 3. And so this is the final answer for this problem. So now you know how to solve a second-order linear differential equation for all 3 cases. Now the next example problem that we're going to try is an initial value problem. So we have y double prime plus 4y is equal to 0, and y of 0 is equal to 4, and y prime of 0 is equal to 6. Go ahead and solve this initial value problem. So I'm going to rewrite the differential equation like this. Y double prime plus 0y prime plus 4y is equal to 0. So we can see that a is equal to 1, b is 0, and c is 4. So we have r squared plus 4 is equal to 0. Subtracting both sides by 4, that gives us r squared is equal to -4. Next, we need to take the square root of both sides. Now we know that the square root of 4 is plus or minus 2. So the square root of -4 is plus or minus 2i. So now we can write the first value of r as 0 plus 2i, and the second one is going to be 0 minus 2i. So we know that r1 is alpha plus beta I, r2 is alpha minus beta I. So we can clearly see that alpha is 0, beta is 2. So let's write that here. Alpha is 0, beta is 2. Now our next step is to write the general solution of the differential equation. So it's e alpha times x, and then c1 cosine beta x plus c2 sine beta x. Now alpha is 0, so we're going to have e to the 0. E raised to the 0 is 1, so that's just going to disappear. So it's going to be 1 times c1 cosine beta x, beta is 2, plus c2 sine beta x. And so that is the general solution to this differential equation. But because we're dealing with an initial value problem, we need to use these 2 points to get c1 and c2. So at this point, we can get rid of everything else. So let's plug in this point into this equation. So y is 4, x is 0, so we're going to have cosine 2 times 0, which is 0, and then sine of 0 times c2. Cosine of 0 is 1, sine of 0 is 0. So therefore, we can see that c1 is equal to 4. Now let's calculate c2. So we need to use the second point. We need to find the derivative of this expression. The derivative of cosine 2x is negative sine 2x times the derivative of 2x, which is 2. The derivative of sine 2x is going to be cosine 2x times 2. So we have y prime is equal to negative 2 c1 sine 2x plus 2 c2 cosine 2x. So now let's plug in this expression. So y prime is 6, and then sine 2x, that's going to be sine 0, so that whole thing is 0, plus 2c2 cosine of 2 times 0, so this is what we have. This disappears. We know that cosine 0 is 1, so dividing both sides by 2, c2 is equal to 6 divided by 2, which is 3. So now that we have the values of c1 and c2, let's plug it in into that equation. So we're going to have y is equal to 4 cosine 2x plus 3 sine 2x. And so this right here is the solution to the initial value problem. Now let's work on one more problem. We're going to have y double prime minus 2y prime plus y is equal to 0. And this is going to be a boundary value problem. Y of 0 is equal to 3, and y of 1 will be equal to 7 times e. In the initial value problem, in the last problem that we did, we had y of 4 is equal to 0, and y prime of 0 is equal to 6. So notice the difference between the initial value problem and the boundary value problem. In the initial value problem, we have a point in the y function and in y prime. In the boundary value problem, we have 2 points in the original function y. And so that's how you can quickly distinguish if you're dealing with the initial value problem versus the boundary value problem. So now let's go ahead and work on this example problem. So let's write a r squared plus br plus c right beneath it. So we can see that a is 1, b is negative 2, and c is 1. Now we need to factor the trinomial. Two numbers that multiply to 1 but add to the middle coefficient negative 2 will be negative 1 and negative 1. So what we have here is a perfect square trinomial. And we could see that r is equal to 1. So we have one real solution, which means we are dealing with case number 2. So let's write the general solution to the case number 2. So the formula is y is equal to c1 e rx plus c2x times e raised to the rx. Let's replace r with 1. So we have c1 e to the x plus c2 x e to the x. Now, our goal is to solve for c1 and c2 using those 2 points. So let's start with the first one. Let's replace y with 3 and x with 0. So we're going to have this. E to the 0 is 1, and 0 times e to the 0 times c2 is just 0. So we can see that c1 is equal to 3. Now let's use the second point. Plugging it back into that formula, y is 7e, c1 is 3, and then it's going to be e to the x is 1, plus c2 times x, which is 1, and then e to the 1. So we have 7e is equal to 3e plus c2 times e. Subtracting both sides by 3e, we're going to get 7e minus 3e, which is 4e, and that's equal to c2 times e. Dividing both sides by e, we can see that c2 is equal to 4. So now we can write our final answer, which I'm going to put it up there. So plugging everything into this formula, we have y is equal to c1, which is 3, e to the x, plus c2, which is 4, x e to the x. So this is the solution to the boundary value problem. So that's it for this video. Now you know how to solve second order linear differential equations. Thanks again for watching.